Hi all, questions 21 is about an open pipe. This is the solution. Substitute all the values accordingly into this formula to get the final answer, which is 0.68 meter. For question 22 is about calculate the frequency of the second harmonic, and this is the solution. Thank you.
Assalamualaikum and hi. I am Madam Madia binti Abdul Manan. Today I'm going to discuss question number 23 and 24. Let's check it out. This is question number 23. First, we have to read the question carefully and write down the information that we can get from the question. Figure 5 shows a whistle of frequency 325 Hz is attached to the rim of a wheel of radius 0.30 meter, which rotates at a constant speed of 6 revolutions per second. An observer stands about 20 meters from the wheel. What is the maximum frequency that could be heard by the observer, given the speed of sound in air is 340 meters per second? From this question, we know that the frequency of source is 325 Hz. This frequency comes from the whistle, which attached to the wheel that has a radius of 0.30 meter. It is rotates by 6 revolutions per second. How do we know that this is omega? We can look at the unit here. The given unit is revolution per second. So what should we do? We have to convert into radian per second. Okay, we do know that 1 cycle is equal to 1 revolution is equal to 2 pi is equal to 360 degree. So from omega equals to 6 revolution per 1 second, we substitute the 2 pi here for 1 revolution equals to 2 pi equals to over by 1 second, then we can get ourselves 12 pi radian per second. Okay, next, the observer stands about 20 meters from the wheel. So this is the observer. Okay, the observer stands means that the observer is not moving, so the V from the observer is 0 meter per second, not moving. The observer is standing. Okay, how far? 20 meter from the wheel. What is the maximum frequency that could be heard by the observer? So the given frequency of air given is 340 meter per second. What is the maximum frequency? So what is maximum frequency? Okay, if you can recall back from the subtopic sound wave, we have crossed by the Doppler effect, and then we go through this graph, the variation of apparent frequency and sound intensity when the source moves towards, passes through and move away from the stationary observer. So if we look here, we have when the source is moving towards the observer, the frequency heard by the observer is greater or larger than when the moving object is actually totally in front of the stationary observer. And then when the moving object is moved away from the observer, the frequency heard by the observer is less. So this frequency when the object is moving towards the observer is the highest frequency can be heard by stationary observer is called the frequency maximum. So this is the frequency that we are going to calculate for this question. what should we do now? First, we write down the equation from the Doppler effect. F naught from the observer equals to V plus minus V naught over V minus plus Vs Fs. Okay, to get F maximum, so F naught equals to V from A 340. The observer, to get F maximum, the object or the source must be moving towards the observer, so positive. V naught, the observer is standing still, not moving, so 0. 340 minus, okay, plus minus minus plus, so plus minus. So what is the Vs here? So the Vs here is from V equals to R omega. So R is 0.3 multiplied by the omega here 12 pi. Then you can get yourself 11.31 meter per second. Substitute the number here. Okay, what is Fs? Fs is from the vessel. So 325. By using the calculator, you can get the equation is 336.18 hertz. We round off the answers correctly, then we can get the answer is 336.2 hertz. So the answer is B. Now we are going to answer question number 24. A guitar string with Young's modulus of 2.8 gigapascal is 0.6 meter long and has a cross-sectional area of 2 millimeter square. If the 20 Newton tension would stretch by the string 2.4 millimeter, calculate the strain energy gain in the string. So first we write down the information that we get from the question. There is Young modulus is 2.8 gigapascal. We have the string here. The length of the string is given by 0.6 meter long. The cross-sectional area here is a 2 millimeter square. Convert into meter. Okay, 1 meter. Okay, 2 times 10 to the power of negative 4 meter square. The tension given is 2 Newton to the string and it stretched by 2.4 millimeter. Okay, convert into SI unit. Make sure all the units are in SI units. So now the question asks for the strain energy. So write down the strain energy equation. There is U equals to half FE. Substitute the number. The force is come from the tension of the tension that given to the string. The elongation here. Okay, then the final answer, by using the calculator we can get 0.024 joule. So the answer is D. Okay, that's all. Thank you.
Okay guys, let's continue by question number 25, which is under topic heat. Alright, so let's read the question first. What do we have? Okay, so a 50 centimeter well insulated stainless steel bar has a cross-sectional area of 3.5 centimeters squared. So be careful here, the unit just in centimeters squared. Alright, so normally we need to convert it to be in SI unit lah, which is meter squared, and for the calculation, one of its end is maintained at a temperature of 115 degrees Celsius, while the other end is kept at a temperature of 30 degrees Celsius. Right, so this is T1 and this is T2 lah. Okay, if the bar is in steady state condition, okay, so this is the situation. Okay, so for any steady state condition, remember dq over dt just remain constant. Okay, find the temperature at a distance 15 centimeter from the end that is at 115 degrees Celsius. So they ask you to find the temperature where its position is 15 centimeter from this part. Alright, so the answers given is A, B, C and D here. So we need to understand the question first. Okay, what do we have here? Alright, so as usual, I think we need to sketch a simple diagram to understand the question very well. Okay, so what do we have? This is the metal. Alright, so the temperature at both ends given as 115 and 30 degrees Celsius. Alright, so they ask you to find the temperature at 15 centimeter from 115 degrees Celsius area. So at this position, they ask you to find T. Okay, for this, I just label it as A for 115 degrees Celsius area, B for 30 degrees Celsius area, and C for the temperature asked in the question. Okay, the total length of the metal is 50 centimeter. And the cross-sectional area given is 3.5 centimeter squared. Alright, so again, so this is the way how do we understand the question. I think normally we just sketch a simple diagram lah to understand the question. Okay, alright, so for the info, what do we have? Alright, so they just give you the length of AC, which is 15 centimeter. I just convert it to be in meter. This one should be in meter, sorry, should be in meter. Alright, and length of AB is 0.5 meter, and then temperature at A is 115 degrees Celsius, temperature at B is 30 degrees Celsius, the area is 3.5 centimeter squared. I just convert it to be in meter squared, so multiplied by 10 to the power negative 4, and they ask you to find the temperature at C. Okay, I think I need to change this one first. Alright, so the unit here, the unit here already in meter, in meter already. So I just cancel out centi, 0.15 meters. Okay, alright. So what do we have here? Okay, so remember, okay, at steady state, what do we have now? dq over dt, and the rate of heat flow equals at any position. So dq over dt through AC equals to dq over dt through CB. Alright, so for AC area, okay, the question is negative Ka dt over dx of AC, while for CB, the equation is negative Ka dt over dx of CB. Okay, and as we know, we are talking about the same metal, so K and K just cancelling each other. Okay, K and K just cancelling each other. Also A and A, because the area is still the same here, they are cancelling each other. Also negative and negative cancelling each other. Alright, giving you dt over dx of AC equals to dt over dx of CB. Okay, so from this, I just refer to this area lah. Okay, between AC and CB, the rate of flow of heat just equal at steady state. Alright, so what do we have now? Based on that, as we have discussed just now, okay, everything just cancelling each other again, negative K also A, then giving you dt over dx of AC equals to dt over dx of CB. So for AC, dt is TC minus TA, and dx is the length of AC. Alright, while dt for CB is TB minus TC over length of CB. Alright, so we just substitute all the values given, which is TA, TB, LAC, and LCB. Okay, we just substitute into the equation so that using our calculator we may calculate the value of TC, and TC getting here is 89.59 degrees Celsius. Okay, so by using the calculator directly, you may get 89.5. But by using 2 decimal places, the answer getting now is 89.59. So based on this, we just refer to the nearer answer given lah, which is 89.5, which is C. Okay, so we just refer to the answer given just now. Okay, according to A, B, C, and D given here, the best answer or the nearer one is C, isn't it? Which is 89.5. Okay, or by using the second method, you may get 89.5 directly. What do I mean? We just use the calculator directly. For example, by using AC and AB, and the answer is getting now directly equals to 89.5. Okay, what do I mean? For example, here lah, at steady state, okay, dq over dt of AC equals to dq over dt of AB. Now we are using different part, AC and AB. So for AC, against negative Ka dt over dx of AC, and for dq over dt, the question is negative Ka dt over dx of AB. Alright, so again, we are talking about the same metals. So negative K and K cancel each other. Same area, again A and A cancel each other. Also negative and negative, they are cancelling each other. So what do we have now? Just dt over dx of AC and dt over dx of AB, which is equal to each other. So dt of AC is TA minus TC, while dx of AC equals to L of AC lah. Alright, while dt for AB is equal to TA minus TB, and dx of AB equals to LAB. Alright, so LAB given is 50 centimeter. I just convert it to be in meter. Also LAC given is 15 centimeter. I just convert it to be in meter. Right, TA given is 115. TA still 115, and TB given is 30. So based on this, by using your calculator directly, you will get 89.5. Okay, so the answer is C. Alright, so this is the answer for question number 25. So remember, at steady state, the rate of heat flow just constant. Okay, at any position, it just equal to each other. Okay, next, let's continue by question number 26. Alright, still under heat, alright, chapter. So, two metals rods given here, which is brass and copper, they are clamped together on both ends as shown in figure 6 below. Okay, so what do we have now? Okay, there are two different metals, which is brass and copper, equal in length. Okay, and then separated by 0.50 millimeters. Okay, at 0 degrees Celsius, both rods are each 30.5 centimeter. This is the length of brass and copper, and separated by 0.50 millimeter at their unfastened ends. Determine at what temperature the rods will just come into contact. So they ask you to find the temperature where these two metals just in contact. Alright, so the values given here, just the coefficient of linear expansion of brass, which is 18.7 times 10 to the power negative 6 per degree Celsius, and the coefficient of linear expansion of copper, which is 16.8 times 10 to the power negative 6 per degree Celsius. Alright, then the answers given is like this lah, A, B, C, and D. So which answer is the best one? Alright, so what do we have? This is the concept lah. Alright, so according to the situation, okay, this is the separation between brass and copper. So at certain temperature, they are in contact. What does it mean? The brass and the copper just expand. And the expansion of brass and copper should be different lah, because the linear coefficient given are different for both metal, which is brass and copper. Alright, so by having contact between these two copper means that the total elongation of both metal now, just equal to the length here, which is 0.50 millimeter, the total elongation of brass and copper. All right. Okay, so what info do we have here? So they just give you the original length of brass and copper, which is 30.5 centimeter. I just convert it to be in meter. Okay, and then after the expansion, they are touching to each other. So the total length of both metal equals to the gaps before, which is 0.50 millimeter. I just convert it to be in meter. And then the linear coefficient of brass and copper given also. Then they ask you to find the temperature where they are in touch now. Okay, so according to the principle, all right, so when the metal just in touch, all right, so the total elongation equals to the elongation of brass plus the elongation of copper. So the elongation of brass equals to alpha original length and delta T of brass, and the elongation of copper equals to alpha original length and delta T of copper. And remember, the original length given for both metal, which is brass and copper, equal to each other. We just take it as L naught nah. Alright. So the temperature, delta T, the change in temperature also the same. So I just factorize L naught and delta T to be like this, multiplied by alpha of beta brass and alpha of copper. Again, LOB equals to LOC. I just factorize it to be L naught. And delta T also the same. I just take out here, factorize it to be like this. Okay. Alright, so you will get this. And then we just substitute all the values. The total elongation of both metal is 0.5 millimeters. I just convert it to be in meter. Okay. And then this is the original length of both metals, still the same. Delta T, okay, leave it first. Alpha of beta and gamma also given. Substitute into the equation so that you will get delta T, where delta T equals to T final minus T initial. Alright, so initially the temperature is 0 given in the question. So we need to find T final, isn't it? So based on our calculation, T final getting now equals to 46.18 degree Celsius. So the answer is B. Alright, so based on the answers given just now, the answers given getting now equals to 46.18 degrees Celsius, which is B. Okay, so this is the way how to answer the question for number 26.
Okay, number 27. Two containers A and B are joined by a tube of measurable volume, as shown in figure 7. The containers are filled with an ideal gas at a pressure of 2.3 times power of 5 Pascal. The gas in container A has a volume VA equals to 3.1 times power of 3 cm cube, and temperature A, TA, equals to 17 degrees Celsius. The gas in container B here has a volume VB equals to 4.6 times power of 3 cm cube, and temperature B, TB, equals to 30 degrees Celsius. So calculate the amount of gas in mole in the container A. Given value here for container A, we have volume in cm cube. So convert to SI unit in meter cube. So volume A equals to 3.1 times power of 3 times 10 power of negative 6. So you get 3.1 times 10 to the power of negative 3 meter cube. Okay, then for temperature A, TA, okay, in degrees Celsius, so convert to Kelvin. So TA equals to 70 plus 273.15 equals to 290.15 Kelvin. Now we have pressure P here 2.3 times 10 power of 5 Pascal. So from here, how to determine N, number of mole? So we can use equation PV equals to N of P. So what is R? R is gas constant. So the value of R equals to 8.31 joule per Kelvin per mole. So now we can substitute the value here. The value of P 2.3 times power of 10 to the power of 5 Pascal, and volume 3.1 times power of negative 3 meter cube, R 8.31 joule per Kelvin per mole, and temperature 290.15 Kelvin. So you get N equals to 0.296 mole. So the answer is A.
I'm going to discuss question number 28. A constant mass of an ideal gas has a volume of 3.49 times 10 to the power of 3 centimeter cube at a temperature of 21 Celsius degree. When the gas is heated, 565 joules of thermal energy causes it to expand to a volume of 3.87 times 10 to the power of 3 centimeter cube at 53 Celsius degree. This is shown in figure 7 below. The pressure of the gas is 4.20 times 10 to the power 5 Pascal. For the heating of the gas, calculate the work done by the gas. Here we are given the V initial as 3.49 times 10 to the power of 3 centimeter cube. Convert to SI unit, 3.49 times 10 to the power of 3 times 10 to the power of negative 2 meter cube. So 3.49 times 10 to the power of 3 times 10 to the power of negative 6 meter cube. Simplify this value, we will get 3.49 times 10 to the power of negative 3 meter cube. So this is V initial. So V final given as 3.87 times 10 to the power of 3 centimeter cube. Convert to SI unit, 3.87 times 10 to the power of negative 3 meter cube. The pressure of the gas. The pressure is given by 4.20 times 10 to the power of 5 Pascal. So we consider this process as isobaric process. So it occurs at constant pressure. So the formula given for work for isobaric process is W equals to P delta V equals P V final minus V initial equals to, P, substitute P, 4.20 times 10 to the power of 5. V final, 3.87 times 10 to the power of negative 3 minus V initial, 3.49 times 10 to the power of negative 3. So we'll get 159.6 joules. Look at the answers given here. The closest or the nearest answer is A. So the answer is A, 160 joules.
Right guys, now we go to question 29. Determine the work done by 4 moles of ideal gas that expand from 300 centimeter cube to 500 centimeter cube at a constant temperature of 60 degrees Celsius. So first, better we highlight the information given and focus on the question want us to find out. Okay, determine the work done. This is the question. Determine the work done. Right, and information given is 4 mole of ideal gas, and then it expands from 300 centimeter cube to 500 centimeter cube. Okay, so we can say that this is a expansion from 300 centimeter cube to 500 centimeter cube. The volume increase, and the other information is the constant temperature. Okay, this one will give us clue. The process of isothermal here is isothermal. Since the volume is increased from 300 centimeter cube to 500 centimeter cube, so this is what we call isothermal expansion. Let us refer to our notes on thermodynamics. Alright, we focus on work done in isothermal process. Alright, here. Specifically, isothermal expansion. So we have two formula here. Work equal to nRT ln V final over V initial, or work equal to nRT ln initial pressure over final pressure. So we will going to choose the first one, which is work equal to nRT ln final volume over initial volume. Okay, so we go back to the question. Where is it? Here. Okay, so the formula we are going to use is work equal to nRT ln V volume, final volume over initial volume. So we just substitute the value of n, which is 4, constants R is 8.31, temperature is convert into SI unit, which is 273.15 plus with 60, and ln, this one we no need to convert into SI unit because it will give the same value. So this is 500 and over 300. Then we take a calculator. 4 times 8.31 multiply in bracket 273.15 plus 60 times with ln 500 over 300. So we will got the answer is 5,656.83 joule. or we can write it as 5.66 times 10 to the power of 3 joule. So the nearest answer will be C. So that is the answer for question number 29. So that's all. Thank you.